Hello, my name's Mariann Lloyd-Smith and I work with a not-for-profit organisation in Australia called the National Toxics Network. We're part of a much bigger global network called IPEN, which is committed, we're all committed to a toxic-free future. Today I wanted to take the opportunity to talk to you a little about unconventional gas, coal bed methane and shale gas, and tell you some of the experiences we have had with that industry here in Australia. In some parts of Australia, communities have lost their homes, their health, their livelihood because of this industry. And recently we've heard that the Indonesian government is very actively promoting coal bed methane and shale in Indonesia, and that Australian companies are involved. So I hope today I can give you a bit of a flavour of the concerns and the worries about this industry. So what I'll do today is I'll clarify what I mean about unconventional gas and hydraulic fracturing. I'll touch on some of the developments that we've heard about in Indonesia. We'll talk a little about the chemicals used and released, what we know and what we don't know. We'll touch on air pollution from unconventional gas and the problem with wastes and wastewater. We'll ask the question, is coal bed methane and shale gas climate friendly in the first place, because that's the reason that governments say that we need to go ahead with this industry. And then we'll end off with some impacts on human health, both here in Australia and the US. And at the end there'll be some PowerPoints with references and resources that you'll be able to access at your leisure. Now the photo just to the left there just shows you what a gas field looks like and some of the infrastructure that goes with it. But so what is unconventional gas and fracking? Well, certainly it takes in three different forms: shale gas, coal bed methane, which sometimes in Australia we call coal seam gas, and tight gas. And nearly all of these require hydraulic fracturing, which is just simply injecting the well at high pressure with water, chemicals, proppants, sometimes radioactive traces, to actually fracture the rocks and allow the gas to escape. Now the difference between these three is that shale is much deeper, uses a lot more water, and always needs to be hydraulically fracked, or fractured as we call it, or fracked. Coal bed methane is slightly different. It's lower, it's less deep, and it requires depressurization by pumping out the water first. And as the pressure declines, then about 40% of the wells are then fracked as well. And tight gas is simply methane caught in the limestone or the sandstone, and they often use acid to dissolve the limestone to allow the gas to run free. So what have we heard about unconventional gas development in Indonesia? Well, certainly we know the government is promoting it very strongly, and they're estimating around 1,500 to 2,500 trillion cubic feet. Now try to remember that number, because it is important as we go on. And certainly we've seen coal bed methane in Sumatra and East Kalimantan. There's a number of projects for shale gas already underway. Tight gas, again, Sumatra, East Kalimantan and Java. And the Australian companies are involved: Lion Energy, Dart Energy and Santos. The top photo there is just a picture of a drill rig, and as you can see, it's not a particularly discreet little piece of infrastructure, and you can imagine when you have to have many hundreds of those in a gas field, because that's the point about a gas field, that as one well goes down you have to drill another one. There's some maps that came from the Indonesian government's presentation to a rather large convention that happened last year on coal bed methane and shale gas. And as you can see there, the government estimates for coal bed methane alone around 453 trillion cubic feet. If we look at shale gas, another map very similar, estimates there are 574 trillion cubic feet. Importantly, the US has said, sorry, that's not quite true. Actually, of that 500 or so, only around 50% are actually recoverable. So we're nowhere near that figure that we originally talked about, the 1,500 to 2,500. It's not only us that are concerned about unconventional gas. The United Nations Environment Programme in 2012 put out a global alert talking about the unavoidable impacts the industry would have. Sometimes it happens when the technology is not used correctly. Other times it will occur despite the correct use of technology. And they're worried about climate impacts, water contamination, air pollution, public health and biodiversity. And there's some photos from Australia that actually show some of those unavoidable impacts. The top two are from a spill of produced water in my state, New South Wales. The second two is the industry trying to deal with its massive amounts of contaminated water that come out when they depressurise the coal bed methane seams. And as you can see, they're either spraying it on the roads or putting it in very, very large ponds, hoping to just literally evaporate. And the last two photos are some photos of air pollution incidents in Queensland. So what do we know about the chemicals used in unconventional gas? Well, there's not only fracking chemicals, there's drilling chemicals as well. Everything from corrosion inhibitors through to lubricants. And you'll often hear the industry, and I'm sure your government will say it to you as well, that the amount of chemical additive is very, very small. Less than 2% of the fluids that go down in the fracking process are chemical additives. But when you actually do the maths, when you add it up, you can see for shale that can be anywhere between 15 to 100 tonnes per frac per well. And remember, we have many hundreds of wells. For coal bed methane, some of the documents we've seen here in Australia talk around 18 to 20 tonnes, and up to about 40% of that is not recovered. It remains in the ground. These are carcinogens, some are neurotoxins, some are sensitizers, reproductive toxins, and most worryingly, endocrine disruptors, because these are the chemicals that affect the way our children develop and grow, and they can be dangerous at concentrations at very, very low levels. They also use a man-made radioactive substance called cesium-137 for borehole logging and measure flows, and the propants, which are these silica-based products. They go down with the solution, they go into the cracks and hold the cracks open to allow the gas to escape. And anything up to 3,000 tons of propants can be used per frac. There's lots we don't know about chemicals as well. There's many secrets, data gaps, and of course man-made mishaps and accidents. But the American Chemical Society last year came out and said, well, of the 190 most commonly used fracking chemicals, 65 had hardly any toxicological information at all. 34 had none. In Australia, only 2 out of the 23 most commonly used fracking chemicals have ever been assessed by our regulatory agencies. The European Commission has expressed a lot of concern over the interactions of these mixtures, and a very important paper came out last year talking about these chlorofluorocarbons and organobromides, which are just where the mixtures come together and form new products and new compounds, and these are both halogenated and incredibly persistent. Most have very little environmental fate or ecotox data, and even when there is information, then a lot of that is protected via trade secrets. And of course we have the unknown impact of the accidents and spills and leaks, and there's a couple of photos of some accidents that occurred in Australia. These are the accidents that the industry and your government will say can never occur. Well, there's some good proof that they certainly do. The bottom one is simply a blowout when the drillers lost control of the pressure with the fracking. The unconventional gas, coal bed methane, shale gas, also emit an amazing amount of air pollution. While lots of people have been focusing on the fracking and the water issue, they've forgotten that air pollution is one of the big issues when it comes to this industry. And the World Health Organization has declared outdoor air pollution a carcinogen in 2013. Now, we know the gas fields and their infrastructure emit this wide range of air pollutants, everything from volatile organic compounds through to particulate matter, through to the BTECs, the benzene, toluene, ethylbenzene and xylene, very nasty contaminants. And the worry about this is this synergy between particulate matter and air pollutants, because what the particulate matter does, it moves into the lung, particularly the very small stuff, and goes deep into the lung and then into the bloodstream. And with it, it carries these organic pollutants, giving a perfect delivery mechanism into your body for these contaminants. The US EPA has gone even further and said many of the unconventional gas air toxics cause cancer and neurological problems, birth defects, and we'll come back to that in a second. And they also acknowledge that they're one of the largest emitters of volatile organic compounds. And as I said, the sources aren't just fracking, it's compressors, the machinery, the drill rigs, the venting, the flaring. Basically, the whole production line produces air pollutants. And this is just from one small gas field in Australia. I chose Santos because it's one of the companies that are going to be working in Indonesia. And as you can see, for those very dangerous volatile organic compounds, they're putting out over 1 million kilograms per year, and this is one gas field alone. We're also very worried about the exposure to radioactive substances, not only the man-made ones like cesium-137, but what's called the naturally occurring radioactive materials, or NORMs as they're referred to. Now, the amount that's in a coal bed methane seam or in shale deposits is very dependent on the age and the salinity, but you are always likely to find thorium, uranium, radon. And we know these are linked to some very serious health problems. Certainly with radon, which is linked to lung cancer and leukemia, the World Health Organization has just said there is no safe level of exposure. Now, when you start moving the NORMs out of the earth and into the air and into the dust, you remobilise them, and you do that via drilling or fracking or the wastewater. And in studies in Australia here, we've seen that there is a 3-fold increase in radon in the gas fields compared to outside the gas fields. And then once they're remobilised, they can be relocated via that particulate matter I talked about. And that can get washed out with rain, and it again provides a perfect pathway to carry these NORMs, these radioactive substances, into domestic gardens and into domestic water tanks. And surprisingly, or not surprisingly, that's exactly where we've found them. Now, unconventional gas has a lot of problems with waste and contamination. It produces huge amounts of wastewater. This wastewater is contaminated with heavy metals and NORMs and BTEX, and it's often referred to as produced water. So when you hear the industry talk about that, it just basically means it's their wastewater. It also produces solid wastes, the salts, lots of salts from coal bed methane, and if you treat the wastewater, you have what's called treatment condensates, the pollution that's left over from your treatment. Those pictures on the side, the top one there, is a photo of a major wastewater treatment facility, and even it can't clean the water to a good enough standard to drink. We have spills. Santos was fined last year for contaminating groundwater aquifers with uranium. They contaminated it at 20 times the Australian drinking water level. Very serious. And of course we have problems with well integrity. Many wells fail. Even the industry acknowledge that wells fail 6 to 7% early on in their career, but pretty much all wells will fail eventually. And we're already finding BTEX in Australian water bores, and we think that is being released from the natural contaminants. And it's also good to remember that coal bed methane, because you're taking so much water out, draws down the water table, something that Santos had to acknowledge in its work. They just refer to that drawing down of the water table as simply an unavoidable impact. So the question, is all of this damage and all of this pollution, potential pollution, really worth it? We're told that we have to do it because unconventional gas is climate friendly. Well, this is what the director of the United Nations Environment Programme said about that. And if you can see it there, for the sake of another 20 years of dirt cheap energy, are we really going to put millions of years of evolution and of ecosystems at risk? Obviously, he doesn't think it's worth it. Why is it so unclimate friendly? Well, basically because it emits large quantities of methane, and methane is an incredibly potent greenhouse gas. It leaks from the pipes and the valves, it gets vented, it comes out of leaking wells, it's apparent in the flaring emissions and just simple fugitive emissions that are the releases that you can't control. And again, some studies in our region have shown a threefold increase in methane concentrations inside the gas fields as compared to outside. And when the Queensland government started to test wells, they found that of the 58 they tested, 26 were leaking methane. We're now finding methane in drinking water as well, which isn't a surprise. We were warned about that by some research that was done earlier by the US. But we're finding methane in drinking water bores, we're finding methane in the coal bed methane discharge water, 68 times the background levels, and it's now contaminating the regional water supplies of Queensland as well. But probably the incident that really shows it to its greatest degree is the bubbling of the Condom River. The Condom River is a river that goes through outback Queensland. It feeds or delivers drinking water to thousands and thousands of people. And since the industry has come to town, we now have it bubbling methane along a 5-kilometre stretch at 80% the lower explosive level. Take it from me, that is an incredibly high level. The photo there is of a well-known rock star in Australia who decided he would go to the Condom River and he would actually surf that bubbling river because that would provide the publicity that we needed to get the government to, examine this issue. What's important is the Queensland government's report on this issue has shown that the methane that the river is bubbling is exactly the same as the methane that the companies are mining. So, okay, we've done some testing around homes near Australian coal bed methane gas fields, and certainly for those residents that lived close to the fields, and if you see the photo at the bottom there, these are the big gas fields, and the residents live around where those yellow arrows are. And the air samples that we tested, and these also were tested by government and industry, found a wide range of toxic volatile organic compounds. Everything from benzene through to toluene, vinyl acetate, naphthalene, methylene chloride. These are very serious contaminants. We also did some testing beside some of the gas structures, gas fields, and found chlorofluorocarbons, which are basically the CFC ozone depleters. Well, for those of us who have been around long enough, we know how hard it was to get rid of those from industry. It is very depressing to see them being somehow formed under the ground and being released near gas fields. And we've also done some testing of the resident drinking water bores, drinking water tanks, and found a range of things like heavy metals, methylene chloride, those norms, the naturally occurring radioactive materials, and cesium-137. So what does this mean for health of the residents? Well, after a lot of campaigning by the residents, they finally got a government health study. It was a very preliminary study and really didn't talk to many of the residents, didn't do very much clinical work at all. But even with this as a preliminary study, they had to acknowledge that there was some evidence that might associate some of the residents' symptoms with their exposure to coal bed methane contaminants, airborne contaminants. And I think that really helped the residents get bought out. There was a lot of work by colleagues of ours, and we now have at least 6 of those families have been bought out by the gas companies. Now, the gas companies say this doesn't, they're not acknowledging any responsibility, but still, the fact that they bought them out, I think it does. The sort of health impacts they've looked at, Dr. McCarran from Queensland, and this paper is now published, reviewed 38 households, 113 people, and 58% of them believed that their health had been impacted, and they reported quite a range of symptoms. Probably the one that worries us most is the paresthesia. That's the abnormal tingling and things in your extremities, in your fingers, and it indicates that there is a neurotoxic agent at work. Importantly, they're very, very similar symptoms as we have seen with people who live near gas fields in Pennsylvania and Texas. And certainly again in the States there's been some work on farm animals and livestock as well, and they have also been affected. Now in Australia we haven't done a formal risk assessment, but in the US they have, and it concluded that living within a half a mile of a gas field, a gas well, gave you a much higher risk of respiratory and neurological effects and an excess lifetime cancer risk. Now I'm going to end on this one. This is about intergenerational equity and the fact that the children that are exposed to this pollution, they are not little adults. They have special vulnerabilities, and an exposure at a critical time of development, either in the womb or as they grow up, can have severe long-term consequences for their health. We've known this for a number of years. This comes from the WHO. But last year we had another study come out showing that mothers who lived close to well pads during their pregnancy had a greater chance of a low birth weight and an increased incidence of congenital heart defects and neurological problems or neurotube defects in their babies. And probably that sort of evidence led our state government to at least say you cannot have coal bed methane or shale gas within 2 kilometres of a village, a suburb, a town or agricultural infrastructure. It hasn't been enough for us to feel comfortable because we know pollution moves many, many miles. And so across Australia there is this movement called gas field free communities, and thousands of Australians have come together to declare their communities gas field free. So I think I'll leave it at that. As I said at the end, there is some references which I don't expect you to read there, but you can look at it later, and there's some more resources which you can follow up at your own leisure. But I hope I've been able to give you just a sense of what this industry can mean to a community, and I hope you're a little bit more prepared for when you face your government and your industry when they say this is so good and you really need to accept it. So thank you very much for listening.